Hi, in this chapter we'll talk about the comparison with a confidence interval. So instead of doing a hypothesis test, we could take the value of p hat and form a 95% confidence interval. This would be similar to conducting a two-tailed test at 5% significant level. Okay, if the proportion from the null hypothesis is in the interval, we fail to reject the null hypothesis. But if the proportion, remember, is the proportion from the null hypothesis is outside of the interval, we reject the null hypothesis. So if you remember what is confidence interval, that means we have two tails cutoff value, and then this area except for the cutoff value, the middle part, contains 95% of the area of the normal distribution. So that means if p hat is in the interval, which means p hat is in this area, we fail to reject the null hypothesis. But if it's outside, such as in this side and this side, if here's p hat, or this is p hat, we reject the null hypothesis. Okay, let's have an example. So in 2008, the Centers for Disease Control and Prevention reported that 34% of the adults in the United States are obesity. A county health services planning a new awareness campaign posed a random sample of 750 adults living here. In the sample, 228 people were found to be obese based on their answers to a health questionnaire. So this response provided a strong evidence that 34% figure is not accurate for the region. So they tell you to construct a 95% of interval for the proportion of obese adults. How does this relate to the confidence interval? So first of all, like I said, we need to extract all the important information. Okay, so what would be our p hat, p naught? So p naught, which is this one. Oops. This part, 34%, that would be our assumption, right? We assume that 34% of the adults in the United States are obese. And then what would be our sample size? Sample size is in the county's health services, they sampling 750 people. And then what would be our p hat? P hat is among these of whom 750 people that they interview, 228 people were found that they to be obese. So we have 228 divided by 750. This is equals to 0.304. Okay. So before we construct a confidence interval, we always need to do is central limit theorem. So independence, randomization, and then failure success test. So we need to test that. Okay, since this is a confidence interval test, not a hypothesis test, so that means instead of use the success test or the failure test, instead of times the p naught or the p sub 0, we need to times p hat. So we have 715 times 0.304, and then the failure rate would be q hat. So they're both greater than 10. So that means we pass the failure success or success failure test. So remember, if you're trying to use a hypothesis test, you're trying to test the failure and the success test should be built around the null hypothesis. It should be p times m times p naught. and then m times q naught. But since this is a confidence interval test, which is based on proportion, sample distribution proportion, so that's why we need to times p hat and the q hat. Okay, so do you remember how to build a confidence interval? We have p hat plus, let me use a different color pen. So the confidence interval should be p hat plus or minus the z-score times the standard error. So what is standard error? Which is the standard error is what? Basically is the standard deviation of sampling distribution of proportion, which is p hat q hat divided by n. This is standard error. So we have 0.304 times 0.696 divided by proportion 750. So, and then what would be our z-score? Since this is a 95% of confidence interval, so our z-score is equal to 1.96. Okay, so our confidence interval equals to what? Use a calculator. We got 0.304 plus or minus, this is our p hat, plus or minus 0.329. So we got the interval is between 0.0211 to 0.33969. You can write it into percentage, whatever way that you feel more comfortable, which is 27.11% to 33.69%. Okay, so based on 95% of confidence interval, our P naught is what? Our P naught is 13.4% or 0.34, which is outside our hypothesis, our proportion from the null hypothesis is outside of the interval, the confidence interval. Let's say outside of the 95% confidence interval. So we reject the null hypothesis. So that means there is evidence shows that and then we state the alternative hypothesis, which is here. We're trying to prove what? This is not accurate for the region. So this is our confidence interval. How does this use a confidence interval to test a hypothesis test? So how does this work? Let me draw a graph, you might be more clear. So when we're constructing a null confidence interval, we are centered with the P in here. So this is, for example, this is our 95% of confidence interval. So this is our P hat. So if our P naught, which is our hypothesis, falls outside of the confidence interval, which is this part or this part, we'll reject the null hypothesis because it's too far off. So let's use the same problem and construct a hypothesis test that we've been learning this chapter and see what's the differences. So I'm going to erase all of these. Or no, maybe I should keep it. I'm going to use a green pen to test it. So the important information should be the same. But for the central limit theorem, if we're trying to use a hypothesis test, the failure and success test should change to m times p naught, because this is a hypothesis test. Let me use a green pen. Hypothesis test. Construct a hypothesis test in the green pen, okay? Okay, so the success value should be 715 times 0.34, which is greater than 10, and then the Q should be Q naught, which is 750 times 0.66, also greater than 10. So even you switch to a hypothesis test, it still passed the failure and success test. So that means, yes, we can run a hypothesis test. Okay, so now we need to what? State the non-hypothesis and the alternative hypothesis. So the non-hypothesis is what? Well, we're trying to prove that P naught, which is our assumption, is 13.4% of the adult in this county has the same obesity rate. But no, that's the assumption. But we're trying to prove that, hey, this is not true in this county. The number is different. If it's different, that means it's not equal to. They didn't say if it's greater than or less than. We just say, hey, this is not accurate. That means it's not equal to. So remember, not equal to means that, hey, this is going to be a two-tailed test. So that means you're going to find the p-value and then times 2. So after we did that, we can either run a sample distribution proportion or a test statistic test. Okay, I'm going to erase this. Let me rewrite this. So our non-hypothesis is when p not equals to 0.34, but we're trying to prove that, hey, the county's obesity rate is different than the nationwide obesity rate. It's a two-tailed test. Okay, again, we just test the central limit theorem. So the next step is we construct that sample proportion. So mu is equal to p naught, which is 0.34, and sigma equals to p naught q naught over n divided by 750. So this is equals to 0.173. So with that, you can construct a distribution of proportion, sample distribution of proportion, with the center 0.34, and then you add 1 sigma, and here is subtract 1 sigma, and here is add 2 sigma, and then subtract 2 sigma. Okay, so we're trying to find where's p hat. So our p hat equals to 0.304, right? That's what we found. So maybe it's around here. So let's say this is 13.4%, and this is going to be our p-value. But remember that this is a two-tailed test. That means your p-value should be what? You need to times 2. That means there should be another p-value. Since it's symmetric, so you can just go ahead and times 2. So now let's use a GeoGebra to calculate that. So we have mu equals to 0.34 with a sigma equals to 0.173. So when x less than 0.304, is equals to 0.0001, and then we need to times 2. So that means this is going to be 0.002. So our p-value after times 2, we should have a p-value equals to 0.0002. Okay. So since our p-value is equals to 0.02%, which is our alpha, it didn't say anything. If they didn't say anything, that would be 5%. So our p-value is less than our alpha. That means our p-value is small. If p-value is small, we reject the null hypothesis with a p-value of 0.02%, and there is enough evidence, there's significant evidence, or statistically significant evidence, let me be more accurate. Oops. Oh, sorry. And then here we state an alternative hypothesis. What is that we are trying to prove that, hey, there's statistically significant, oh, I forgot that, evidence that 13.4% figure is not accurate for this region. Remember, this part is you need to fill in the alternative hypothesis. So here's the comparison of confidence interval and the null hypothesis. Now, so you can either use a confidence interval to test the hypothesis test, or use our traditional way. Or do you remember there's another way, is testing statistic. You can also try it by yourself. Let me know if you have any other questions.